Hello again. Today I'm going to be walking you through what you're going to be doing for lab exercise 6. This will be the last lab of the semester, and it's a little bit longer than the labs that we've done previously, so this one is going to count for more points. So if you missed a previous lab for whatever reason, this will help, this will count more and help bring up your score for the laboratory portion of this course. So for this lab, we're going to focus on patterns in our solar system. So you're going to be using another simulation program, and I'm going to walk you through some things you might encounter and kind of the navigation to that and what to expect when doing this lab. So the name of this website is nineplanets.org, and they have a simulation that very interactive simulation that allows you to walk through and fly to different objects in the solar system, whether that be planets or moons or comets. And so I've included a link here to the website. This lab is going to be due on Thursday, April 22nd by midnight, of course. That is going to be the last week before finals week. So finals week is this week of the 26th through the 30th. So I've included some screenshots here to help you navigate through the site and some general directions about navigation and such. But I'm going to walk you through this in this video tutorial. So I included the link here. You can control click from a Word document to go to it. And I want to show you something you might run into. All right. So I've been working with this website for the past week writing this lab exercise. And this message I just started getting today. This is due to their security certificate. The date expired yesterday. I have reached out to the website. They are going to fix it. However, you can still navigate to it. So just in case you get this and it's not corrected before by the website host before you start to work on the lab, if you get this message, you can click this advanced and you can click proceed anyway. So what this is saying, the language here is very misleading. No one's attacking your information. Their security certificate is expired. You're not going to be asked to enter any personal information on this website. It's just running a simulation. So it's perfectly fine to go ahead and proceed. All right, so when you go to the website, you will see a page that looks like this, right? So go ahead and click start. And it might take it a moment to load. It's a pretty intricate simulation. So then you will be taken to this screen and it says click the screen to run the model. So go ahead and click. Now this default that it comes up to is going to give you a view of the solar system. Itself, right? And so to navigate, if you're using a computer with a mouse, you can use the mouse wheel to scroll, zoom in and out, right? You can also click and drag to rotate the view, like so. And so for this first part, you will be looking at the direction of rotation of the planets in our solar system. So orient the screen so that you can see top down, and you can start it a little more zoomed in. So we're going to actually start the simulation of running, and look at the direction of orbit, of the planet's orbit around the sun, and also minor planets and asteroids and the Kuiper Belt. So hit this play button here. It will automatically bring the date to whatever date you go into the simulation, right? So this is the current time and date. Before we get into that, there's another scale here on the right. So you can also use this slider scale to zoom in and out. So you want to click this play button, and when you do, you will get a pop-up that looks like this. Okay, so you want to click play, and so this will start the simulation to rotating, right? And so for this first part, you're going to look at each of these objects, and you're going to look at their direction of orbit, right? So their path around the sun. What direction are they moving? Clockwise or counterclockwise? Yeah, you'll have to zoom out to see the other planets, and the Kuiper Belt. By the way, this inner portion here, all these little things going around, is the asteroid belt. So remember, the Kuiper Belt is icy bodies on the outer part of the solar system that lie in this plane of orbit, right? So don't confuse the Kuiper Belt with the Oort cloud. The Oort cloud it contains similar bodies, however, it creates a spherical shape around our solar system, as opposed to being in the plane of orbit of the other planets. And what I mean by that, you can see that most of the orbits lie in this 2D plane, right? These, I believe, are comets, and if you'll notice that their orbits lie above this plane, right? So you're looking at the direction of orbit of the planets in the solar system, and also these outer bodies. So to look at Neptune, Uranus, and Pluto, and the Kuiper Belt, you're going to need to speed up this to see their motion, right? Because it takes them longer to go around the sun. So if you advance this to the speed of the simulation to faster, we're now at 1 year per second, you can see the rotation of all of these objects, right? And of course, these are moving really fast. But, okay. In the next part, you're going to look at specific characteristics of planets. And so I chose this simulation program because it's pretty cool. So again, you can zoom in and out anytime. When you get ready to leave this part, you can hit X here. And so if you double click on any planet, let's double click on Venus, then you will fly to that planet and you will be able to gather information about it. Okay, so for this first part, or the second part, I should say, you're going to be gathering data from the encyclopedia here. So you're going to fill in this table for each of the 8 planets. Remember, Pluto is not a planet anymore. And the other part here, in the next part, you're going to look at the structure and label the structure and composition of the planets. right? So if you click this structure tab, then you'll be brought to a view like this that shows the internal structure of the planets. In this first part, when you're gathering information and filling in this table, I've then asked you to pick out 2 patterns from the data that you just took, right? So you're looking for patterns within the solar system, right? So for instance, maybe you notice that the temperature of the planets gets lower, it gets colder as you move out farther away from the sun, right? So if that's what the data shows, that general trend, then that's one thing that you could list for that. And then I've also specified to note any observed exceptions to the trend. So in general, maybe you do see a trend of lower temperatures as you get farther out from the sun, right? So you would look at this column compared to the surface temperature. But maybe one of the planets does not fall into that strict pattern, right? So maybe Saturn is warmer than Jupiter, right? So this is an exception to the trend, and you would note that for that problem as well. Right? So part 2 is going to be labeling the interior structure and composition. So you're going to label each of the layers. Let's do Venus again. Structure, right? That is the name of that layer, what it is made of, and also the state of the physical state of the layer, whether it's solid or liquid. Now, for the last part, you're going to be looking at the moons of the solar system. So these are all of the major moons of the solar system. I say major, there are a lot more moons or bodies orbiting planets besides these, right? But these are the main ones, the largest, the ones that orbit the closest to their parent planet. So how you find these, anytime if you click on this solar system, it will take you back to this view. Okay, and so here I've listed, of course, Earth first. Let's go to Mars. Right. So if I double click on Mars and I fly to Mars, the planets that have moons will have this planet system tab here. Right. So if you click this planet system tab, it will zoom you out so that you can see the major moons that orbit that planet. Right. So for Mars, it's Phobos and Deimos. And then if you double click on Phobos, then you will be brought to a similar page with an encyclopedia entry where you can gather information about that particular moon. Okay. And so the things that I've asked for the moons, you're going to be looking at the rotation period compared to the orbital period for each moon. So notice that the rotation period and the orbital period is the same for these. But these are not the same, these do not describe the same thing, right? So recall that the rotation period refers to an object's spin about its own axis, right? So for example, the Earth spins once in 24 hours. Its orbital period is the time it takes it to go around its parent star, right? Or, I'm sorry, parent planet, right? So these moons are orbiting planets. Like, so for example, the orbital period for the Earth with respect to the Sun is 365.25 days, right? So that refers to the orbit around whatever it is orbiting around. In this case, you're looking at moons, so around their parent planet. And the rotation period refers to their spin about an axis internal to their body, right? And for the third part, or the third column here, I've asked for the shape, right? And this is a very general. You can either put spherical or irregular, right? So when I say spherical, I mean perfectly spherical, right? So like our moon, it looks really round. Phobos here is more, I would say, irregularly shaped. It has a lot of craters. It looks more like a little asteroid, right? Look, it's got this big old dent on the bottom. It looks like a potato, right? So if it looks like a potato, it would be an irregularly shaped moon. Let's zoom back out a second. So looking at some of the outer planets, let's go to Saturn. Saturn has the most moons that I've asked about. For Jupiter, Jupiter also has many moons. However, I've only asked you for the main 4. Okay. Saturn has a pretty intricate lunar system, though. So, for instance, you should have read about Titan in your reading, right? So Titan is perfectly spherical and looks like a little mini planet or a planet on its own, right? And then you have Hyperion, which again kind of looks like a potato, right? So the moons vary a lot by size, shape, etc. But you're looking for patterns in this data. And then I ask you a couple of questions about it. All right. So that is going to be your last lab of the semester. I hope you find this one enjoyable. I thought this was a very kind of neat simulation to look at objects in the solar system and gather data. So, yeah. So that's all I have for you, and good luck.